Htv-X. Htv-X, also known as the new Space Station Resupply Vehicle, Japanese,
新型宇宙ステーション補給機
Hepburn, Shingata Uchu Sutshan Hokyuki, is a Japanese cargo spacecraft of the Japan Aerospace Exploration Agency, JAXA. Designed as the successor to the H-2 Transfer Vehicle, HTV, for International Space Station, ISS, resupply missions, it was first launched on October 26, 2025. The Htv-X cargo spacecraft is manufactured by Mitsubishi Heavy Industries, Limited, MHI, with contributions from Mitsubishi Electric Corporation, MELCO. IHI Aerospace Company, Limited provides the propulsion system and American company Sierra Nevada Corporation, SNC, provides the common berthing mechanism, CBM, and hatch kit. Htv-X consists of three main modules, arranged from top to bottom on the launch pad. Unpressurized Cargo Support System, UPCSS. Unpressurized cargo is mounted externally on top of service module, rather than inside the spacecraft, allowing larger items limited only by the launch vehicle fairing and increasing capacity compared to the original HTV. Service Module, SM. A 2.7 meter long, 8 feet 10 inches, unit capable of independent operation. It includes two deployable solar arrays generating 1 kilowatt of power, replacing the original HTV's 200-watt side-mounted panels. Batteries with a 3 kilowatts peak output, up from 2 kilowatts, and upgraded communications with a 1 megabit per second link alongside the previous 8 kilobits per second channel. Htv-X omits a main engine, using a ring of reaction control system, RCS, thrusters for propulsion, and mounts some components externally for easier astronaut access. Pressurized Module, PM. A 3.5 meter long, 11 feet 6 inches, section with an internal volume of 39.6 cubic meters, 1,400 cubic feet, and a payload capacity of 4,070 kilograms, 8,970 pounds. Identical in design to the original HTV, it is positioned at the bottom of the stack to improve mass distribution. The Htv-X cargo spacecraft measures 8 meters, 26 feet 3 inches, in length. It is launched by the H-3 Medium Lift Launch Vehicle, MLV, with a payload fairing widened to 5.4 meters, 18 feet, in contrast to normal 5.2 meters, 17 feet, and Payload Adapter Fitting, PAF, widened to 4.4 meters, 14 feet 5 inches, to allow increased structural strength and accommodate the side hatch. Reusing the pressurized logistics module design from previous HTV reduces development cost and risk. Concentrating RCS thrusters and solar arrays on the service module simplifies wiring and piping, lowering weight and manufacturing cost. External loading of unpressurized cargo enables larger payloads, limited only by the fairing. The goal is to have costs while maintaining or extending HTV capabilities. Simplification was expected to reduce launch mass to 15,500 kilograms, 34,200 pounds, from HTV's 16,500 kilograms, 36,400 pounds, while increasing maximum cargo mass to 5,850 kilograms, 12,900 pounds, from 4,000 kilograms, 8,800 pounds. Other proposed payloads for replacing the unpressurized cargo module during ISS resupply missions include external sensor packages, an International Docking System Standard, IDSS, connector for automated docking, satellite rendezvous trials, piggyback small satellites, station return capsules, assembly of lunar mission modules, and acting as a space tug to store resources such as recyclable materials, excess propellant, and spare parts in orbit for future use. In May 2015, Japan's Ministry of Education, Culture, Sports, Science and Technology, MIXT, announced a proposal to replace the HTV with an improved, cost-reduced version preliminarily called Htv-X. The proposal of Htv-X in 2015 was as follows. To reuse the design of HTV's pressurized logistics carrier, PLC, as much as possible, except for adding a side hatch for late cargo access after the spacecraft launch vehicle integration. To replace the unpressurized logistics carrier, ULC, avionics module, and propulsion module with a new service module. To load the unpressurized cargo on top of the service module rather than inside the spacecraft. In December 2015, the plan to develop Htv-X was approved by the Strategic Headquarters for Space Policy of the Cabinet Office, CAO, targeting launch in fiscal year 2021 for the flight of Htv-X1, Technical Demonstration Vehicle, by the H3 Medium Lift Launch Vehicle. As of June 2019, NASA's Flight Planning Integration Panel, FPIP, had set the launch of Htv-X1 for February 2022. With the Japan, U.S. Open Platform Partnership Program, JPUSOP3, agreement in December 2015 to extend cooperation on ISS operations through 2024, Japan will provide its share of ISS operation costs with the form of transportation by Htv-X, and also possible use of a small return capsule. An early concept included a side hatch of pressurized module for late cargo loading, but the final 2021 design removed it. Late access now uses the ISS docking hatch, requiring a payload adapter fitting with access opening on the H3 rocket's upper stage. Due to the delay of H3 development, the launch of the first Htv-X slid to 2025. Htv-X1 was launched successfully on October 26, 2025. As of 2021, an evolved version of Htv-X called Htv-XG is being considered for transporting cargo to the Lunar Gateway, or simply Gateway, as part of the Artemis program. As of April 2025, 3 flights were planned to resupply the ISS. As of December 2024, Htv-X4 and Htv-X5 are tentatively planned for launch in Japanese fiscal year 2027, Japanese fiscal year 2029.